My name is Craig Little. I'm one of the solution architects for North America for the West. We've got a fun, fact-filled agenda to deliver and have some fun with today. We're going to talk a little bit about this concept of how do I get to a Linux kiosk. It's not an easy journey. There's a lot of potential pitfalls, rabbit holes, side quests, lots of fun things that we need to talk through. But we've got a great solution in that Linux kiosk sort of design. Well, let's talk a little bit about who I am. Like I said, I'm one of the strategic solution architects for the West, and so that means I have a lot of those big name customers that you think about on the west part of the United States. This particular customer is one that I had the pleasure to work with earlier in 2024, and they make kiosks. They've been making them for a lot of years, since 1992, and they do some really cool stuff with these kiosks. Lots of them in use, but today they are Windows-based. And Windows, not terribly innovative, and so they talk to us and go, hey, we want to make a move to doing kiosk with Linux. And so we sat down with them, we found out they do custom cabinets. They make their own cabinets with drawers and sensors and trays to put the computer hardware in. And that's all full custom. And then they work with specific hardware vendors for the motherboards, the touch screens, the barcode scanners, the fingerprint scanners, all of those pieces to integrate. And this is predominantly used in a clinical space. So that brings with it a whole slew of fun things that we have to take care of. One of the biggest is we have to meet HIPAA and PPI certification pieces. So we can't have unencrypted data. We can't have everybody under the sun accessing these systems. If somebody walks away with a hard drive, they can't get the data off of that hard drive. There's a lot of fun requirements that we had to fold into this solution set. These are deployed typically to larger customers with multiples of these cabinets in a site. So think about hospitals, nursing stations. There will be a cabinet in the nursing station. Things of that nature is where these are being put. We also had to look at integrating to the customer's clinical data and identity data. So not all of the data lives within this solution. So we've got to do these have to have these integration points. And like I said, previously, they've been run Windows as the OS for these kiosks forever. So that's been a well-defined, well-understood solution, but not innovative. And so that's the part that we're really moving forward with. And that was one of the questions that we asked. As SUSE, we asked this customer, is why? Why do you want to change? What are those reasons that's prompting you to move away from a known entity? A lot of those are things that I'm going, okay, this is why I would do it. But some of it is, one of the bigger ones is open source innovation. They wanted to be able to refactor their application and really fundamentally change the application to run Kubernetes instead of the old school multi-tier SQL Server kind of design. So open source innovation, Kubernetes, two of the key elements. A GetOps model of development to where I can constantly be doing development and releasing features. I want to add this feature, or I want to potentially add a feature and go, hey, that'll be an extra $100 for that feature, and things of that nature. So that GetOps model of engineering allows for those faster turnarounds. Because I've spread my application out. It's not a big monolithic thing. I spread it out into multiple containers. It makes life easy. Security. We talked about the HIPAA, PPI types of requirements. Windows can be secured, but it's getting a little long in the tooth, and there are more exploits going against it. The other part of it is, if you get somebody that is able to lay hands on those systems, because these kiosks are in places where others can lay hands on it, it looks like their desktop at home. So it's one of those things that I kind of know what I'm doing, and they can go in and break things. So security is one of those pieces. Windows not keeping up. New customer needs. The market leader, new customer needs, time to market with new features really feeds back into the GetOps and that ability to innovate and deliver new features quickly. So some of the requirements, security. You know, I parked that one first because that is one of those key elements here. Kubernetes. The customer had already started going down the road of developing their app in Kubernetes. So they'd already made that decision to do the Kubernetes side of things. The HIPAA and PPI compliant solution brings with it, you know, a laundry list of things that you have to take care of. One of the biggest is full disk encryption to where the data cannot leave, or if the hard drive leaves, the data is gone or locked up. Managed centrally. You saw on the first slide, we've got about 40,000 nodes potentially, you know, at when we're fully deployed to be able to manage. So there's a lot of pieces that you got to pay attention to when you're trying to work at that kind of scale. Quick question for you. What kind of scale, number of devices would you guys be managing at?
Right now we have about 1,200 stores, so we're looking at probably around 5,000.
Okay. So hefty enough. Not quite the same, but still it's the exact same challenges. You just get away with a little more a little more sloppiness on occasion. Integrate with the custom hardware. This is one that you don't have that particular issue, but in this custom hardware, there's drawers that pop out. There's all sorts of components that have to integrate with the OS and the OS solution. So that brings its own technical challenge. Long support life. This was one of the big pieces that was very important to this customer because of the fact that due to the scale, they don't want to have to go out and update with the service pack every year. And so they are looking for a long support life. In the Windows world, they had a 10-year support life. And that's kind of unheard of in the Linux space because the Linux pieces are moving relatively quick. So there was a piece that we were able to kind of factor in on that part. We already talked about the full disk encryption and then the scale to 50,000-ish nodes across US and Canada. So there was a lot of really key solution requirements that came back, and when you start looking at product mixes, it's like, well, this one can handle this one nicely, but this one does the full disk encryption with TPM integration. How many of you done full disk encryption with TPM? It's a pain in the butt. Windows handles it okay. Linux, not so much. You know, I was grasping at various projects to pull in those pieces, but that was one of the key requirements that led us down the road to one of the solution pieces. So let's talk about the journey. This was the fun part, because this is where we started with hey, what are you guys doing for Edge and clinical desktop kind of question? And that's where we started with the roadmap discussion. What are we doing? What's the technology? Some of those sorts of things. It was a great starting point. We got to a point where we're going, we can do some things. Let's do a proof of concept to make sure this all matches. That's where the fun started. You know, we started talking success criteria. There was a fair amount of customer education. These guys were really good at doing Windows kiosks. They knew how to manage them. They were doing some really cool disk manipulation pieces, disk partition manipulation. They knew that part inside and out. Move them over to Linux, it's a whole new world.
Were they still domain joined group policy?
I don't believe they were using domain group policy pieces, but I don't know specifically. They had not. I don't think so. Right, right. And so I'm not sure the full answer to that piece. Yeah, it was one of those, And this is to that customer education piece. You had very sharp, capable individuals that just hadn't learned the Linux side of things. They were doing image-based deployments. Yeah. And they had this cool dual partition. Yeah, this dual partition where they could boot into the second partition and it would rebuild the first. It was some really, like I said, really innovative, cool stuff that they were doing. Didn't understand Kubernetes, didn't understand Linux. Exactly, exactly. Really refined 15-year-old tech. Yep. So we had to work through some customer education kinds of issues. And that, frankly, was some of the fun part, and it was some of the part that took the longest to kind of work through as we were going through the technical pieces. Resource gathering. That's where, on the back end, the sales guy and myself in the solution architect role, we're going and grabbing product management team, we're grabbing domain expertise and solution experts around the edge pieces, pulling all together to be able to deliver the technical components of the solution. So there's some fun stuff there. 2 calls a week. I got to know these guys really, really well. Great team, love chatting with them. But 2 calls a week where we were all on these calls, and I had product managers on the calls, I had my bosses on the call, sales leadership on the call. We had everybody. And the good thing is, through it all, we were able to get product management alignment, and we were able to get success. We delivered a Linux-based kiosk with the GUI running in a container on the device. And in that container, or the pod, we actually were supporting X as well as sound with that, all running inside of a container. It's some cool stuff. And
Envision more when you, for this, that there was like a server or something running containers in the kiosk, or just more or less down terminals that connected to
nope.
containers.
So we've got
Run the
whole thing, one box. So it's a big physical cabinet, 1 server chassis, and it's running Kubernetes. And then the GUI display is running as a container on that server. So there's some,
Like a PPI section in the container?
more so, we're passing hardware pieces through, or OS pieces that represent the display and represent the hardware, through to a container that starts X. And then starts an application. Yeah. It is a web-based interface, because we're only opening a single instance of the application. But for our demo purposes, we were using Firefox as that app.
Now, could you have gone the route of having more of like a server running containers and then those kiosks just being like thin clients more or less?
Could, because we could have done KVM, have the X running as a full virtual machine on the same server, sort of design. Oftentimes, like the Windows design, the display manager is running natively on the operating system. That was an option. But when we start looking at this overall stack, let's talk through some of those design questions and design criteria pieces. So, custom hardware. This is not their cabinet. Their cabinet's much prettier. But I needed an example kiosk piece in here. But we had that custom hardware. Like I said, it's a 6-foot high kind of big cabinet with drawers and all sorts of automation built into it. SLE Micro ended up being our operating system choice. How many of you guys are familiar with SLE Micro? A little bit? Guys in the back row at least should be, right? Yeah. SLE Micro brings with it a lot of good, but some interesting challenges. So SLE Micro, for those of you that don't know, is an immutable operating system. So read-only root, read-only etc, parts of R. So you can't manage it in the same way that you manage normal general Linux. SLE Micro got pulled into the mix because of full disk encryption enabled with TPM. That's built in SLE Micro 6 out of the box. So it was one of those like, okay, disk encryption handled. That was one of the big pieces. SLE Micro doesn't have or doesn't run X natively. There's no GUI included.
You did that so they couldn't pull the drive out.
And walk away with data. Because there's patient data that lives on these and other clinical data. So full disk encryption kind of took us down the road of using SLE Micro. SLE Micro doesn't support X natively. And so now I still have to present an application on the screen for the clinical staff to interact with. So with that, that's what took us down the road of let's do X in a container. We're already running container services on this box. So we did that, and it actually adds to the overall security footprint. So I get good security from an immutable OS. I have to do transactional updates to go mess with configuration and do updates. If my GUI is in a container, if they break out of that, what do they have access to? Only what's in that container. They don't have access to anything else in the system. So there's another security layer. SLE Micro also comes with SE Linux built in. So we get an SE Linux layer running through there. So it gives us a solid secure footprint to run as an operating system. So on top of SLE Micro, we are using SUSE Multi-Linux Manager. How many of you guys are familiar with MLM? Of course you are, Stefan. Yeah. Stefan happens to be the product manager for Multi-Linux Manager. So we're using that to manage the 50,000 nodes of the machines. Rancher K3S. Initially, we had Rancher pulled in to do the Kubernetes management, but as we kind of work through solution, Rancher really isn't going to be able to manage at the scale we need to. Because we got 50,000 individual Kubernetes clusters. They're single node clusters, but there's still a lot of them. So we're actually going to use MLM to manage all those Kubernetes clusters. I got Salt. I can do a whole lot of cool things with Salt and Salt states and configuration management pieces. So that's what we're going to look at using there. K3S, spectacular single node Kubernetes engine. It does a really nice job. It's lightweight, does everything you need it to do. If we want to do high availability, I can do it with just 2 nodes. I don't need to do 3 nodes like you do with typical RKE. So we've got some good options there. And then the custom kiosk software runs on top of all of that. Yes?
Some sort of networking requirement?
There is. Yep. And so we'll talk about that in a little bit more depth right here. So we do have a call home, and previously that was running on site servers. So they had site servers deployed at all of these customers. The goal is to not have site servers anymore. So we're pulling back to cloud-based instances. And that's, actually we got another slide that we'll talk more in depth. Just kind of as a recap of the technology in place. Multi-Linux Manager, operating system, patching pieces, configuration, and automation. This is where, like I said, we're pulling those components out of MLM, SLE Micro, security layers, SE Linux, immutable OS, full disk encryption with TPM. And again, all of that's really straight out of the box with little, we didn't have to do much to that. Kubernetes, K3S, gives us the nice tight footprint. And then Rancher Prime, again, we were looking at it for fleet management, and we can do, so fleet is a subset of Rancher Prime, if those of you that are familiar with Rancher. It is our GetOps agent to say, we declare the config to be this, fleet makes sure it gets there. Fleet, we can scale much larger than we can Rancher. And so we can actually run fleet as the open source project outside of the Rancher interface. But really, we can do what we need to do because we've got 50,000 nodes that look exactly the same. I can do that kind of automation using Multi-Linux Manager. So that's our overall goal. So those instances run up in the public cloud. the integrations to the clinical data and the identity data is running up in the public cloud. So the nodes just have to go up there to get those pieces, bring them down, and take care of things. So there's some fun pieces that fall into that technical stack. So here's the fun that we had. So SLE Micro 6, it was in beta when we started this process, when we started this POC. So I'm downloaded beta 4, beta 6. You know, it was pretty hardcore for those components. Say hi to Dr. T for me. Thanks, guys. It was in beta. It was a little painful because we hit some bugs and some issues in those beta instances. Understanding full disk encryption. That's one where I had looked at it, you know I can go and encrypt partitions, I can do this, but that concept of full disk encryption being enrolled into a hardware key, that's a whole new animal. It's pretty well documented, but the key element is making sure you have access to pull all those packages in and then get it configured to handle it on startup. Because that's the big piece you get with the TPM encryption is when the machine starts up, it goes, yes, this is the machine that this hard drive was tied to, I will go ahead and boot. If you don't have that and you have to put in a passcode, you're not going to share that encryption pass key with all of the clinical staff. So again, learning, understanding some of those pieces, SLE Micro 6 made it easy for us on that particular front. SLE Micro 6 did not support X. Packages weren't part of it. It was designed to be an edge operating system with nothing but a command line interface. It caused some effort there. Transactional update model. How many of you have used SLE Micro 6 or SLE Micro 5.5? And again, Stefan, your product's based on it right now, at least for a moment. But the transactional update took some getting used to, because if you make changes, add packages, make configuration changes, I have to reboot into those new changes because it's a forward snapshot model for the transactional update. So installation of System Manager, what, it's about 5 reboots? Or is it 6? It's a pretty good handle, or pretty good handful. Well, if I screw up and have to do 2 commands in between reboots, that's on me. But but it's a different approach that you got to get used to. And again, the Windows guys were used to rebooting, so that one helped. And then locking down the GUI. Handing a GUI as a kiosk. You guys have all hacked a little bit. You know, you walk up to that kiosk and go, what if I hit, tap the corners, hit the 3-finger salute and various other key combinations. So how do I lock this down? This is actually really well understood in that Windows kiosk world. They've built the pieces to handle that pretty well. There's kiosk mode as a start, but Microsoft has kind of gone after that business. And I have to admit, I get it. You go to a convenience store, there's 3 kiosks right up against the front. I can go buy Bitcoin, I can turn in my coins, and I can go buy cell phone SIM cards or whatever. There's kiosks everywhere. And all of them, all the gas pumps, they're all running Windows until now. And I know this is my goal for SUSE is, dude, we figured this out, go sell the hell out of this. Because this is a cool space, and when you make a sale in this space, it's not 1,000 or 100 nodes or 1,000 nodes. It's 50,000 nodes. How many gas stations does AMPM have? Or QT or Circle K? But anyway, how do we lock this down? We had to figure that out. Firefox has got some GUI or some kiosk mode in Firefox. But if I'm presenting some other application, I now got to go figure out how to lock that app down. K3S. One of those things, didn't quite expect it. K3S networking pulls a whole different namespace, whole different network range inside of Kubernetes. The previous efforts that they had done around containers, they were running them in Podman. Doesn't have the same networking. They pulled it into Kubernetes, and all the microservices broke. So it took some time and effort to figure out those pieces. SUSE Manager Rancher. This is when we start going, oh crap, we're doing 50,000 Kubernetes clusters. Rancher's going to fall over. We're not going to be able even to start carving it up into grouping. It's going to fall over. We're not going to be able to do that. SUSE Manager. There, I can scale SUSE Manager. We're looking at about 8,000 nodes per SUSE Manager server. I can scale that far higher than I can with Rancher. And then SUSE Manager supports a hub architecture, so we're able to manage it at scale like we need to. I know, I'm going to throw out, we've got one customer at 90,000 nodes. Is there one bigger? That's a North America customer. Okay. But it's just, okay, so 140, 140,000? It's doable. So our 50,000 is well within what we have done. We're not going to use it. We're just going to use SUSE Manager. What? Because it was part of the journey. Because typically we're talking Kubernetes, you talk Rancher Prime to go manage Kubernetes. So it was part of the overall journey, but as we start digging into the details, again, I've got salt states, I've got other cool things that I can do with SUSE Manager that I can go lay down those Kubernetes pieces with. So deployment at scale, customer networking, because of the fact we are putting these kiosks in customer sites, utilizing their networking, so we had to be careful about what requirements we had. So we really needed to narrow it down as to, I can go out over 80, 443, and I might be able to go ask for a couple of ports. But I really can't ask for bunches. So that was a fun part of that. And then the last part, and most of you guys probably don't have to run into this issue, but from my position, I had to go talk to 4 or 5 different product managers and go, hey guys, I know we're doing something weird here, a little odd, but look at the scale, look at the opportunity, I need you to support this. So I had to go talk, like I said, there's one of the guys, Francois Xavier, FX, we call him, who's going to support that GUI container. We've got some pretty stringent framework on what we're going to support there with the overall goal of, Mr. Customer, you bring your app, but here's the framework you can put your app in to where we expose the right pieces out of the underlying OS to make X and make sound work. So we've got that kind of support. So I had to go to these guys and bring them in, have them meet the customer, have them go through these pieces. One of the things from a lessons learned is the training piece. Very sharp Windows individuals did not have a clue on Linux. I absolutely would have, had I done this again, we would have gone through some education work early in the POC process. To where it's like, okay, let's get to a level playing field before we dig in on all these technical details. You know, you're smart, you know a lot of things, but you don't know these things. And so I think a really half-day deep dive workshop would have done us a world of good. Saved a lot of time and effort further down. So that training aspect becomes huge when you're trying to make that move. What's your name there in the back corner? Travis. Travis, good to meet you. Training. Keep that one in mind. Because like I said, it was one of those things, you know, I'm 3 months into this going, dude, had I just gone on site, set up a half-day workshop, and it's like, guys, we're going to focus, we're going to level set on this technology. It would have made a world of difference. So kind of keep that one in mind. Okay. So the technical stack post, all of the challenges, all of the efforts, yes? No, they had a full app that they put into that kiosk mode, and then that kiosk mode, it was a Windows app running. And then they would actually bounce out of that to actually to go out and do configuration, to where they had an admin login that a tech could come in and do, that would bounce them out and then back into it. Again, 15-year-old tech that they'd been refining for 15 years. Yeah, you break out of it and use a set of credentials and away you go, kind of thing. With Linux, it became a little bit of a different animal. You could do that. And that's someplace I talk about that we pulled off. How many of you guys have used Cockpit as a management tool of the operating system? It stands up a web browser. What's kind of cool, because of that web browser being stood up, I had them integrated in their app to where they could go do some Cockpit things, to go manage networking, to go do little sorts of things. And so in their app, they could, again, have that admin login. They go over and presents a couple of options out of the Cockpit tooling. So it was one of those, okay, this is kind of some cool integration points. So Sleep Micro 6 still was our choice of operating system. GUI running in a container with sound support. That will be products supported. So this isn't something they're doing on their own and they got to go figure it out all themselves. We are going to have full product support. The hardware integrations, this was fun. Fingerprint scanner, barcode scanner, the equivalent of a cache drawer. All of these pieces had to be supported inside of the container. And that all worked pretty well. A lot of it came down to what parts of the slash devices or slash dev directory structure that you needed to expose into the containers. And once you get that part done, it really worked pretty well. The fingerprint took a little more time, a little more effort, because there's some library pieces that you had to make sure were there. But we got all of those hardware integrations pulled in. Loved K3S. That part was dead on from the beginning. K3S is a solid single node Kubernetes cluster server. Works well, easy to install, easy to upgrade to the new version. That one was always very, very solid. Rancher Prime sucked. We could not scale it. Even just pulling Fleet as a project out really didn't scale well. But Linux, the multi-Linux manager is a great tool set to allow us to do the levels of management and automation that we need to do. Cockpit integration, spectacular. Like I said, that was very cool to have them be able to pull those pieces in, call them, and present some OS configuration kind of options into the application. New kiosk image, this was fun. So we ended up pulling in some engineers from our OS team to work with these guys. Again, they've got two partitions on the hardware. And so he is going, the guy that manages the images is going to deliver a Linux image to that second partition via their current tools. And they're going to be able to reboot and in a very short time take it from a Windows-based kiosk to a Linux kiosk remotely with just a reboot. We had to do some learning around partition tooling and some things of that nature, but we're able to deliver the new images remotely to that second partition and reboot and reload the first partition very cleanly. It was some very, very fun stuff. Okay, Edge. So Edge, this is a classic Edge use case. Falls into so for Edge, we define it near, far, tiny. So near Edge is remote office, someplace that I have data center-like kinds of capabilities. Good power, good networking is near Edge. Far Edge is now I'm not in a data center anymore. I don't quite have the same networking. Typically, it is consistent networking and I've got decent power, people might be able to access the equipment. This use case is really a far edge kind of use case. Then we have tiny edge, which is embedded, little devices, things of that nature. But our edge stack that we have here is built on top of Kubernetes. And what I like about it, not a lot of it fit necessarily into this solution, but it's the edge team that stood alongside me to build the solution and to support it for this customer. But with it, we get a lot of cool components here. I'm going to flip to this side. Some of the interesting ones, and we are looking to integrate this as they move to multi-node Kubernetes clusters. We should have Acri up here someplace. I'm not seeing Acri. Acri is one of the projects that we are supporting. Acri allows me to look at the hardware of the Kubernetes node and associate specific containers to that hardware. You and I were talking, Paul, about cameras. So I want to know if I've got a camera plugged into just one of the nodes, that pod needs to run on that node so it can interface with that camera. Acri is the tooling that allows me to do that. Some really cool pieces. NATS gets me a message bus. So potentially I might want to take how many times people have logged in. I want to take some of those statistics and push them back up to an instance in the public cloud. NATS is the tooling for that. The Multis, Metal LB, Cilium, all the networking pieces. KubeVirt. This is, again, not necessarily in this particular use case, but I can load KubeVirt on an edge Kubernetes cluster and support my Windows instances I might need. This is a great solution set when we start looking at retail edge. Podman is one that we are looking at. That's more at the OS level. SLE Micro, we built a tool called Edge Image Builder. It allows you to easily create new images in an easy to manage fashion for deployment. We build it and to integrate with Elemental, which is our rancher management of operating system images for your Kubernetes nodes. But in this particular case, the customer is using Edge Image Builder to customize that image that they're pushing out to all of these kiosks. So we're not using the Elemental components, but we're using it to the Edge Image Builder to build those pieces. Metal LB for load balancing, and those are some of those key elements of our Edge solution stack that you might look to incorporating into your own sort of solution. Actually, how to build your own. So Windows or a GUI environment in a container, it's kind of cool. Building from scratch, you got to know a lot of pieces. But SLE Micro, do take a look at SLE Micro. It is a cool operating system. I would not use it as a desktop because that transactional update model is a little rough. But if you're looking for that lightweight, out at the edge, more secure for your solutions, SLE Micro is the solution. Okay. If you want to do it truly kind of as a simple kiosk, absolutely. But you're going to do the container-based desktop in that mode because it's tight. Oh, we talked about support early on. I forgot to mention this piece. SLE Micro has a 4-year support window. I don't have to upgrade it for 4 years. There's no service back in that 4 years. The upgrade is really very easy because, again, snapshot into the new version, reboot. And so, but with that 4-year support model, gives you lots of time before I have to upgrade my operating system pieces. Most of the configuration, most of the applications aren't at the OS level. So I don't have a whole bunch of systemd stuff to care about and things of that nature. All of my application pieces are running in Kubernetes. K3s, Kubernetes engine, cool stuff. SUSE Edge, we've got, again, that whole stack that we're supporting. The Wallboard project, Andrew Gracie is one of the Edge domain experts, technical PM, I'm not sure what his real title is. But Andrew was working on this wallboard project, and that's the basis for a GUI environment in a container. So you can go take a look at his GitHub in that Helm chart, and it's a good starting point to what are those disk directories that I need to expose up into the container to allow you to see the displays, the screens, and how to start X. So it's a good starting point. Container-based desktop. How many of you guys are familiar with OpenSUSE? Hopefully most of you by now, because there's a guy sitting in the technology showcase from OpenSUSE. But we've got Aeon is a project kind of under the OpenSUSE flag. It's actually one guy that's really running this. Pretty good community around it. But it is a Linux desktop with everything running in a container or in containers. And this is frankly as I want to get started and playing and use it in a lab kind of setting. There's your starting point, is the Aeon project. Because it's a little more polished than the wallboard project, the wallboard chart. But wallboard was for a specific use case of I need to stand up a single display, a single application. The Aeon project is a desktop running where all of the pieces are containers in that space. So that's a great place to start looking at that concept of kiosk window or a GUI as a container sort of design. Questions? I know I've been talking and not giving the option for questions. Go for it. Say that again. We have not deployed the migration pieces into production yet. They're starting with, I'm deploying it as an image and shipping the container or shipping the kiosks out in the short term. That's the starting point. And once everything clean, tested, we're all good, then they'll start doing the migrations. The overall design, because this is based on what they've done in the past with this dual partition design, to where the second partition is designed as a bootable partition and it'll come up and overwrite the first one. And so the basic concept is I delete the first partition, the second one comes up and boots and recreates it. So we've not bricked anything yet. Haven't tried to yet either. But these guys are hardcore. It was at the first build of it was really a system restore from a Windows perspective. I've got issues, I just delete the first partition, reboot the kiosk, second partition comes up, overwrites it, reboots it again, and you're back to a known good state. But now we're going to update it and have Linux be pushed back down onto that first partition and have the Linux design done. So it's, I'm excited to see when we get to that point. But like I said, we're starting on deploying new containers or new cabinets with Linux built. Because that's, they're going to have to come back and do some engineering to support the hardware that's already in place. So starting with new cabinet, new hardware on Linux, and then they'll go out and update the rest of the world from there. So again, thank you guys for joining today. Appreciate it.